All right, you should be familiar of the three forms of linear equations. The first one is standard form, where you have a coefficient times x plus a coefficient times y equals a constant. In this form, a, b, and c are integers. No fractions or decimals in this form. And another thing about this form, in most textbooks, not all textbooks, but in most textbooks, a is positive. So we don't have a negative leading coefficient. That first coefficient on x is positive. That's not always the case, but that's generally the case. So a, b, and c are integers, and a is positive. Notice x and y are on the same side of the equation, and then the constant is just by itself on the other side. The most familiar form for students is called slope-intercept form. Your y equals mx plus b. M is your slope, and b is what we call the y-intercept. So they call it slope-intercept form. Most students are comfortable with slope-intercept form. They like slope-intercept form because you can put this in the calculator. If you're familiar with the graphing calculator, it has that y equals button. And so you can put this in the calculator and graph. If you're familiar with how to do all of that, that's great. If not, you really don't need it for this course. It's actually faster to graph by hand. But you have the calculator if you want to double check or just look at it. You are able to do that if the equation is in slope-intercept form. Again, m is your slope, b is your y-intercept. All right, the lowercase b here, unfortunately, is not the same as the capital B here. It's kind of confusing, but those are just the letters that are standardly used in algebra. So capital B is one thing, lowercase b is something else. Finally, we have point-slope form. We're going to look at this more in section 8.5 a little later on. This one's not as familiar, but it's very powerful. It's very helpful. We'll see this later. Y minus y1 equals m times x minus x1. And m is still the slope. And the x1, y1 is where students get a little confused. So the y with the little subscript 1 and the x with the little subscript 1 go together as any point on the graph. It doesn't have to be an intercept. It doesn't have to be any particular point. Sorry, handwriting's rough. So x with the little subscript 1 and y with the little subscript 1 is any point on the graph. So any point you have and the slope, you can create what we call point-slope form. And we'll look at that more again later in the chapter. So let's start with graphing from standard form. Standard form is nice and pretty, no fractions or decimals, all integers. If you want to graph from standard form, you need at least 2 good points. And by good, I mean no fractions, no decimals. 2 good points. So here's an example where the equation is in standard form. Notice all of these values are integers, and the constant can be divided by each of these coefficients. That's what makes standard form so nice. So if your equation is in standard form, and the 2 coefficients on x and y can both be divided into the constant nicely, then you can just use the y-intercept and the x-intercept to get your 2 good points. You can plug in 0 for y and get x, plug in 0 for x and get y. Makes it so easy to graph. So on this first one, if I plug in 0 for y, that's 4x plus 3 times 0 equals 12. Which is really just 4x equals 12, which is easy to just divide it. You get x equals 3. You can even do that whole process in your head by covering up the 3y and just seeing 4x equals 12 and dividing that easily in your head to get 3. You can do the same thing to plug in 0 for x. That would be 4 times 0 plus 3y equals 12. Which that's just going to be 0, so you really have 3y equals 12, and easily divide to get y equals 4. Again, you can really just cover up the x term. you'll see 3y equals 12, divide both sides by 3 to get 4. Quick and easy if these numbers divide nicely. Those will be your 2 good points. So we're going to plot 3, 0 on the graph and 0, 4 on the graph. With those 2 good points, hopefully you have some sort of straight edge. Connect them, excuse my digital handwriting, with a straight line, and you have your graph. So if your equation's in standard form, you just need 2 good points. You can get those 2 good points by plugging in 0 for x and solving for y and vice versa. Plot those 2 intercepts and you've got your graph. Let's try that again. Here again, we're in standard form. The constant 18 can be divided by 2 and 3. That tells us that we can get nice clean values for x and y here. If I plug in 0 for y, I should get positive 9 for x. If I plug in 0 for x, I will get negative 6 for y. So nice and simple. Really don't have to show any work if you can just divide those 2 in your head. So let's graph the point 9, 0 here. And graph the point 0, negative 6 here. Connect those with a straight line, and you have your graph. Always draw your line across the entire grid nice and straight through those 2 points. I will provide you with a ruler during the quiz and the test. You can always bring your own, but I do have some rulers so you can make nice straight lines. All right, let's look at the last example here. If I plug in 0 for y, I get positive 4 for x. If I plug in 0 for x, I get negative 4 for y. Nice and simple. So we have 4, 0 for one intercept, 0, negative 4 for the other. So you have a straight edge, nice straight line through those 2 points to graph your line. So graphing from standard form, if the 2 coefficients divide nicely, you just plug in 0 for x and y and get the other values. If those 2 coefficients do not divide nicely, the best thing to do is solve for y, which we'll talk about a little bit later. So that's graphing from standard form. Now let's review graphing from slope-intercept form. Hopefully you've seen this before. You need just 1 good point and the slope. So the slope will give you the other good point. So starting at 1 good point, using the slope to get another. When you're in slope-intercept form, this is also called graphing form, you want to pull off your y-intercept, which is your constant here. So that's when x is 0, y is positive 3, that's your y-intercept. And your slope is the coefficient in front of x. We don't see anything there, so it's a positive 1. And your slope always needs to be a fraction. So this will be 1 over 1. If you remember, slope is rise over run. So if you don't have a denominator, it's going to be a positive 1. So we're going to start at our y-intercept, and we're going to move based on the slope. So we're going to start at 0, 3. We're going to move up 1 because it's positive and to the right 1. So from this new point, up 1 to the right 1, next point. Up 1 to the right 1, next point. You can make as many of these as you like, at least 2 or 3. I just keep going till I'm out of space. So you have several points following that slope, and then you just connect them with a nice straight line through them. So that's starting at your y-intercept and moving with your slope. Let's try that a couple more times. So here our y-intercept is 0, negative 5, and our slope is 2/3. So we're going to go up 2 and to the right 3, starting at our y-intercept. So we're going to start at 0, negative 5. We're going to go up 2, right 3, up 2, right 3, up 2, right 3. Sorry. Just a few times until you can really see your pattern. They should all connect with a straight line. So that's how you move. You start at your y-intercept and move with your slope. Last example here. We have y equals negative 3x plus 4. The y-intercept is 0, positive 4. Your slope is negative 3, and we're going to put that over positive 1. So keep your negative with the top value. Your bottom number is positive. So we're going to go down 3, and we're still going to move to the right 1. The 1 is still positive. I always like to have the denominator positive and the numerator negative. That way I don't get mixed up. So I'm going to start at 0, 4. 0, 4. From there, I'm going to move down 3 to the right 1. Down 3, 1, 2, 3 to the right 1. Down 3 to the right 1. Just enough times till I can see my line all the way across the grid. So hopefully you've done that before, your y-intercept and your slope. So it's graphing from slope-intercept form, nice and simple. Let's just review horizontal and vertical lines. Last little bit here. So vertical lines are lines that go straight up and down. It's always an x equals value. And students get that a little confused because vertical we think y, even though it's graphing an x value. So if x is always 3, y is not in the equation. Notice we don't have any y. So y is called unrestricted. That means y can be any value we want it to be. It can be any value. I always pick a negative, like -5, 0 is a good number to pick, maybe 3, and maybe 10. So pick a negative, 0, a couple positives, nice and simple. So we have, if we plot those points to the right 3, down 5, to the right 3, 0, 3, 3, and 3, 10. Notice we're going to the right 3 every time. And it's creating, ooh, that was terrible. Sorry, that should be going through those points. It's creating a vertical line. That's horrible. There we go. All right, sorry about that. The slope here is called undefined, and we'll talk more about slope in the next section, section 8.4. But this is undefined slope. Perfectly vertical lines don't have slope because it just goes straight up and down. Same thing here, if you were to graph x plus 5 equals 0, that's x equals -5. So at -5, we're going to plot points all along where x equals -5 the whole time. And again, it creates, try to do this one a little bit better, a vertical line. There we go. So anytime there's no y value in the equation, you're going to have a vertical line. And what we have is undefined slope. We'll talk about slope more in section 8.4. Oh, sorry. Not mean to move the screen there. Undefined slope. All right, let's talk about horizontal lines here just real quickly. Nice and simple again. Graph the line y equals -7. So y is -7. X is unrestricted. We can have any values here. We can use the same ones, 3, 10. Here we're going to go down to -7 and plot all those points. It creates a horizontal line. So horizontal lines are always y equals values. They have what we call 0 slope. It doesn't tilt one way or another, it's just 0 slope, it's just flat. And we have y, if we want to graph y -8 equals 0, notice there's no x value. When there's no x value, that's just y equals 8. We'll just go to 8, and we'll plot some points along y equals 8, to the right and to the left, and it creates this flat horizontal line with what we call 0 slope. So when there's no x value, it creates a flat horizontal line at the given y value. And that's all the review we're going to do, and we'll continue chapter 8 in class.